Right. Now we can see the input devices. So input devices will input things and it will go to the main memory. Main memory has two components in the computer. So that is called RAM and ROM. RAM means, random access memory. Whatever the programs currently running in your computer is stored in the random access memory. So if you want to check this, you have a mechanism. So are you using a Windows computer or joining using a mobile phone?
Windows.
Windows computer, right?
Windows.
So
Windows.
can you see the task manager there, over there in the
Yes, sir.
bottom, right? Can you right
Yeah.
click and go to the task manager? Right click
Yeah.
on the taskbar and go to the task manager.
Processors.
Performance. Done.
Okay, you will see this kind of thing. So you will
Performance.
see, okay, this kind of thing. So this screen or the small compact one,
The big one. Big one.
you
Few
get
more
big one.
details.
Right. If you don't get the big one, just click here. You can see more details. අර ලොකු එකේ එන්නේ නැතුව ටිකක් පොඩි එකක් එනවා නම් compact version එක එනවා නම් please click here. මෙතන fewer details කියලානේ තියෙන. ඒකේ තියෙනවා more details කියලා. Click on that. Right. Then you can go to the more details. And then to go to the performance tab, the second tab, performance. දෙවෙනි tab එකේ තියෙනවා performance කියලා. Can you see that?
Yeah.
Right. When you go to the performance, you will see this kind of thing.
Yep.
Right. First thing is CPU. Click on that. That is CPU, Central Processing Unit. It shows the speed of your CPU and the type of your CPU and also the maximum speed and the utilization, number of processors running over there. Right. Number of processors running. Right. Can you tell me how many processors are running there? Just
203.
3?
203.
203. So 3 is an impossible figure. And
No,
threads.
203.
Threads means part of process, right? So process means program in execution. A running program is called a process. Then thread means part of that process.
Yeah.
No? So threads independently, threads are running. But they are using same data, same programs. So, but threads different threads are responsible for different purposes. Okay, let's say in MS Word is running as a process. Then one thread is running one thread is running for spelling and grammar checking, or that underlining things. Underline when. So one thread is running for that. One thread is running for auto saving. තව එකක් auto save වෙනවනේ නේද? recover වෙනවනේ document එක. Automatically save වෙනවනේ time එකේ time එක recover වෙනවා කියලා. Right. One thread is running to display the text. One thread is running for maybe auto correcting. Likewise, in MS Word is single process, but there can be multiple threads running over that single process.
Yeah.
Handlers means basically, so they will look at. So these are the sensors. Handlers means the sensors. Those sensors are looking at what users or what will happen in the environment.
Mine is showing 98,000.
Yeah, it can be. They're very big. So click, for an example, click is a handler. Double click is a handler. Mouse up is a handler. Mouse down is a handler. You can say mouse over is a handler. Mouse move is a handler. Right? Likewise, so key press is a handler. Key up is a handler. Likewise, there are a lot of handlers responsible for each of these events. These are called events actually. So මේ events බලා ගන්න කට්ටිය තමයි handlers ලා කියලා කියන්නේ. ඒ කියන්නේ key press කියන්නේ event එක. ඒක බලා ගන්න කෙනා handler. key press කරා මොකද කරන්න ඕන කියලා. key up කියන්නේ key එක උඩට එනවා කියන්නේ event එකක්. ඒක බලා ගන්න කෙනා handler කෙනෙක්. Then key down is a event. Mouse move කියන්නේ event එකක්. Mouse up කියන්නේ event එකක්. Mouse down කියන්නේ event එකක්. Double click කියන්නේ event එකක්. ඒව බලා ගන්න කට්ටිය තමයි handlers කියලා කියන්නේ. එන්න handlers ගොඩක් තියෙනවා. මොකද කොච්චර දේවල් වෙන්න පුළුවන්ද? object කීයක්ද? desktop එකේ right click කරොත් එකක්. මෙතන ගිහිල්ලා right click කරොත් task bar එකේ එකක්. start menu එකේ right click කරොත් තව එකක්. button එකක් උඩ right click කරොත් තව එකක්. fold එකක් උඩ right click කරොත් තව එකක්. There are a lot of handlers, right? So understood
uptime,
the concept, right?
yeah.
Yes, sir.
Our uptime is mine is showing 11 days. No, I
Sorry?
switched off it. Uptime
Ah, okay.
only
Then,
showing
Yes, sir.
11 days, 19 hours, 17 minutes, 18 minutes.
Yes, sir. Mine shows 6 days.
so basically, I think you have not turned off the PC, is it?
No, no, I said
No, sir, we on.
I
Uh-huh.
Yeah.
I said I have
This
night.
one, right? Uptime, right?
Yeah.
Okay. Then,
So does Mac have this processor?
no, Mac has a separate different one called activity monitor. It has activity monitor here. Same purpose, but it's like it's different tool. It's not task manager. Here you can see this, all the processors, and you can see CPU. Then you can see so what are the
Yeah.
utilization threads and processes. Same thing, different utility. These are called utility software. Then when you go to the memory, right? Please go to the memory. Sorry, I couldn't tell one thing. Here, this one, socket means the physical processing units, physical processor, physical chip, you can see it's one. So your one is, I believe it's one.
Which one? Physical chip. Where is it?
Socket.
Yeah, sir.
Yeah, even
So
mine
that's
is
why.
one.
Physically processing unit, processor kiyat තියෙනවද කියන එක තමයි socket කියන්නේ. This one. CPU, when you come to CPU, this is the unit. Right? මේ වගේ unit එකයි සාමාන්‍යයෙන් ඔයාලගේ සාමාන්‍ය අපේ computer එකක තියෙන එකයි. මේක තමයි මේ මේක කියලා
So
කියන්නේ
only
මොකක්ද?
one
This
no, we
is,
can
you
fix.
can see one.
You can't fix more than one, no.
Can put in servers there are multiple,
Oh,
but in our computers, this personal computers, no. So this are not using this multiple. The double socket boards are also there. Double CPU, right? Double CPU motherboards are there, right? Here you can see.
Oh,
Not double,
so for
even
gaming,
more.
oh.
yeah, for gaming computers, do they use or
These are here. You can see
oh,
X
for gaming?
yeah, X79 dual Intel Xeon. Yeah, they are high performance computers, workstations, gaming maybe. Right. So it's possible to install multiple. So even for 2, 3, 4 likewise. So in servers there are more. Right. Even 4 socket, maybe 4 CPU motherboard. It's possible, right? Those are there.
Oh my God.
Huge.
You like so many RAM slots.
Yeah, you can see number of frames. Like so, because usually what we see is one. Usually
Yeah.
what we see is one. That is usual case, but it can be multiple, right? So here, so socket means that how many sockets that you have, right? Cores means inside this logically. So inside logically or physically, inside the CPU. So there can be multiple cores. Multiple cores means multiple ALUs. But you can't physically see this, right? Outside, you can't see that from outside. But inside that, so for an example, i5 might have quad core, 4 cores,
Oh,
or dual core, 2 cores. But that is there, right? In one socket, but 2 cores inside that CPU. One socket, but 2 cores. So that is possible. So here in this image, it shows 2 cores. That's means physically how many ALUs are there? Your one, I think. So what is the value? Is it 2?
four. Mine's
4?
four.
4.
Yeah.
Okay. Quad core. Right.
Oh,
2 or 4?
Mine is four. Both of us are four.
both of
4.
us
Then
four.
it is quad core. Okay.
Yeah.
Logical processors, how many?
Four.
I have four. Yeah, same four.
That is then quad core. So we call these processors like 2 cores, then dual core, and logical processors. Based on logical processors, this hydrate is, so it's logically means it's acting like 4 independent processors. Even though you have two, those two are acting like four independent processes. එම් වෙන්න පුළුවන් chef ලා දෙන්නෙක් ඉන්නවා kitchen එකේ, but two chefs are acting like four chefs.
Oh,
Double work, double the work. So one chef can act like two chefs.
Four chefs can act like
කෑම
8
දෙකක් හදනවා. It's possible. Right?
Oh, nice.
Okay, so you can check this utilization of each by just right clicking here. මෙතන right click කරලා. You can see view draft to or change draft to logical processors කියලා එකක් එනවා නේද?
Yeah, that's now it
You can
shows
see
us 4.
CPU performance in task
so CPU
manager.
0, 1, 2, 3. 0 के लिए बटन है.
Change draft to logical processors. When you change draft to logical processors, you will see this one, right? Okay, something like this. You will see something like this. Change draft to logical processors. Here, actually, you can see 20 logical processors, but I don't think that you want. This is i9, so some CPUs, high performance.
Oh, i9.
Oh my god, i9 7th gen.
Yeah.
Right.
i9 means, yeah.
You can
It has
see
10
here.
cores, 20 logical processors.
Yes, sir, 20 logical processors, and you can see altogether 5 into 4, 20.
Oh my god.
Super fast one, and you can see 32 GB RAM.
Super expensive
Oh.
also. Oh my
32.
god. Look at the speed.
So anyway, you can change draft logical process and see the cores separately, right? Okay, memory. Then go to the memory, and it shows. So what is the current utilization and what is the availability? And when you go to the memory, it shows the current utilization and availability. And one additional thing I couldn't explain here, that is this cache. Can you see the cache?
Yeah, L1, L2, L3.
L1, L2, L3. L1 cache is inside, so that is SRAM. This is static RAM, right? This is not normal RAM. This RAM is inside the processor. L2 is also inside the processor. L3 is outside the processor but attached to it. So these are some additional memories inside the CPU and attached to
virtualization?
CPU. Virtualization means whether you can run multiple operating systems by creating virtual computers inside your computer.
There's another thing called Hyper-V support.
Yeah, Hyper-V support. That is also the same, carries the same meaning, Hyper-V, hyper virtualization.
Oh.
Okay. Right. If it is enabled, then that means you can install a virtual machine, virtual PC, and then install some other operating systems by creating virtual computers. Okay, so now you know a lot about your CPU. So cores, logical processors, and threads, utilization, speed, likewise, everything is there. And when you go to memory, you can see the utilization as well as the remaining part and the memory speed. RAM, performance, task manager. Since I don't have, I'm showing this using images, right? Because I don't have the Windows. I can show in Mac, but in your case, you need it in Windows. So when you go to this, you can see, okay, now you can see 16 GB RAM, roughly 15.9 in 16 GB, and available is 4.9, utilized 10.9. And this is SODIMM, small output, dual inline memory module, and speed of the RAM is 1600 megahertz. This is called the speed of the RAM.
DDR3.
Sorry? Yes,
DDR3, right?
This one is DDR3.
And
then you can
DDR3.
see, okay.
That's DDR4.
Then you can see the page pool and unpage pool. What is that? That's what I said that. Page in means you don't load everything to the RAM. For an example, when you read a book, you don't read everything at once. You are not going to read every page at once. You select some pages and you read those. Similar to that, the random access memory will not load the entire program at once to the RAM. Then it's overhead. And for an example, if you take Photoshop, it's around 4 GB, 2 GB to 4 GB. So if you load entire Photoshop to RAM, 4 GB is gone. Word, it's around 1 GB, 2 GB. If you load Word, then 1 GB or 2 GB will be over. So if you use like that, you can use only 2 or 3 programs at once. But RAM is smart enough to select some pages, not the entire thing. It will select, it will divide first into the pages. These pages they are in virtual memory or hard disk. Hard disk, there's a small part called virtual memory. A virtual memory ke tama pages තියෙන්නේ. Hard disk එකේ තියෙනවා virtual memory කියලා එකක්. You can check that by going to my computer properties or this PC properties and then go to the advanced tab. Then you can go to the performance. In the performance again the advanced tab. Then you can see the virtual memory allocation.
1 minute.
Right? So that is something extra. So we learn that in operating systems, right? Not now. But then මේ fundamentals නේද? OS වලදී ඔය ඉගෙන ගන්න තියෙනවා. හැබැයි මම ඒකට background එකත් එක්ක තමයි මේ හදන්නේ. Okay, now you can see these are the things in the random access memory. Okay, when you open a program, try to open a program and see this bar. අලුත් program එකක් open කළා මෙන්න මේ line එක දිහා බලන්න මොකද වෙන්නේ කියලා. What's happening in this line?
There's a small spike.
Yeah, there should be shifting. When you open something, it should shift up, ne?
Yeah, it's going up, then after down.
Again down?
I close the program.
You close the program, then otherwise it cannot go down, right? The processor behave like that. When you open a program, processor will go up, process will go up, and again it will go down. That is for the processor. But memory, if you want to open a program, it will go up.
Now it's
open another program.
It shifted one line up.
Yeah. You can open another program and see. You can open few programs now. Right. Try to open 4 or 5 programs together and see what's happening.
There is a still same small spike.
Try to open 2 programs and see what will happen. 2, 3, 4, so 5, you can see 7, when you monitor this, you can see this line. This is like a timeline. So when you open a program, you can see this is shifting up. Open another program, again it's shifting. Open another program,
you
again
close it, everything is going down, sir.
Sorry?
When you close the program,
when you close the program, it goes down. When you open the program, it goes up, goes up, goes up. But what will happen if you open too many programs?
PC will be slow.
Yes, computer will be slow. Why? Because your memory don't have space to keep that program. So if your memory is already allocated enough, so for an example, 90% or 98, now 69%. So what will happen?
The disk is running at 100%.
Which one?
Disk 0.
Which disk 0 or disk that is disk writing and reading. So that can go up to 100%. That is okay. So that is not.
Yeah, so there's nothing. There's no percentage showing in memory. There is in the side, right?
You can see.
Yeah, there is 48.
But if it is like 95%, 96%, then your computer will be slow. Right? And in the other hand, the CPU will be go up and go down. Based on when it has a process, CPU will go up. But when no processors, it will go down. So that is the nature of CPU. So, but when you are idle, if CPU is still running, your computer is idle, you keep it idle, but you can see your processor is going high. Means some error. That means a virus is either using your system, or antivirus is using your system to scan the virus, or updates are using your system to install the updates. Some background process is running, which is hidden to you. You have to be careful on that. Understood? Yes, CPU එක idle වෙලාවෙත් CPU එක වැඩ කරනවා. When you idle also, CPU is running. You have to be extra careful because it can be a virus. It can be antivirus too. Antivirus එකකුත් run වෙන්න පුළුවන් virus scan කරන්න idle time එකේ. Or it can be update. Anyway, some background processes.
Someone hacks our computer.
Sorry?
Someone hacks our computer.
Not hack. Oh yeah, hacking can also be. So anyway, through this, what you have learned? Through this, what you have learned? So this diagram, right? So, but I know. So it's normally no one is explaining like that. But to explain this diagram, I have used that. How? Because whatever you put will go to the RAM. The current programs are stored in the RAM. Now, can you remember this without by hearting? මතක තියාගන්න පුළුවන් ද කටපාඩම් කරන්න නැතුව? All the current programs, current data will be loaded into RAM. You saw it, no? Practically.
Yeah.
Okay. So when you close the program, it will sap out from the RAM. When you open the program, it will sap into the RAM. This is called actually sapping. When you open a program, it will sap in. When you close the program, it will sap out from the RAM. Okay, that is how main memory is there. What is ROM then? What is read-only memory? What's the responsibility of that?
That is the, I think, the hard
You
disk
store the
or
data.
storage device.
No, it's not hard disk.
I
ROM,
mean, the
read-only
secondary
memory.
one.
Store the device. Store data.
Sorry?
Store data.
In ROM.
Yeah.
Yeah.
Mhm.
Like 1 TB hard disk, those.
Hard disk is here in the storage.
Yeah, that comes under ROM, right?
No. Storage device is separate thing. ROM is separate. ROM is coming under main memory. Okay, ROM, if you don't know, ROM means it's a small chip in the motherboard. Right?
Oh, then ROM is different.
Yes.
All these
No.
days I was thinking opposite.
ROM chip in laptop motherboard, you can see it's very small chip. So this is the ROM chip in the motherboard. You can see this micro level one. This one is the ROM chip in. This is in laptop motherboard. But if it is in desktop motherboard, it will be quite larger. But you can see this is the ROM chip. This is the
Looks
ROM
like
chip.
an IC.
It's IC. This is the ROM chip in motherboard. You can see. Right? ROM is a chip. Here, this is the ROM chip in the motherboard. So it has sometimes it shows this BIOS thing, basic input output
ROM,
system.
yeah, ROM stays in, like it's in the motherboard or else it's in the processor.
It's in the motherboard. Motherboard. It's in the motherboard. ROM means ROM chip. Here you can see this is the ROM chip, ROM BIOS chip. This is the ROM BIOS chip. And in this image, you can see this is the ROM BIOS chip. So likewise, the different motherboards, you can see there's a separate chip, right? That is called ROM or ROM BIOS. ROM means read-only memory that has the program stored by the manufacturer, right? Here, that has the programs. It's a special memory chip which is used to store firmware. Firmware means firm it's a manufacturing firm. Firmware means stored by the manufacturer at the manufacturing plants. There is a software, special software stored by the manufacturer. Why this software installed to this chip? Because that's how each hardware devices are recognizing each other. That's how the motherboard recognize RAM. That's how the processor recognize motherboard. That's how the keyboard recognize motherboard. Mouse recognize motherboard. And that's how the VGA recognize motherboard. RAM recognize VGA. RAM recognize the monitor. Or ROM recognize or whatever. Anyway, people, so hardware will not recognize. If you have like two pen drives, one pen drive will not recognize the other pen drive. Physically two pen drives දෙකක් තියෙනවා නම් වගේ අතේ, you can't transfer data from one pen drive to another pen drive because those will not recognize each other. What you have to do, you have to put it to the computer. Then computer has something called drivers. Those drivers are special software by the manufacturer, right? The manufacturer of the particular device, there's something called drivers. Driver is again firmware, special software by the manufacturer, which is used to identify and communicate with other hardware. So if you don't have drivers, USB drivers, no USB device will be recognized. But operating system basically comes with the USB driver, or earlier days it was not. ඉස්සර දවස්වල USB drivers වෙනම දාන්න ඕන. But now operating system basically comes with USB drivers, so you can plug and play. Plug and play means you can plug and it will work. But earlier days, printers and all, So nowadays also printers and all are coming with some CD. That CD has the driver by the manufacturer. Scanner might come with a CD, has a driver from the manufacturer. Mobile phone can come with a CD, it has a driver from the manufacturer. Right? Similar to that, in refrigerator, smart fridge, there are drivers and firmware by the manufacturer. That is stored in the ROM. Washing machine, there's a software. That is a driver and it's a firmware. So given by the manufacturer. A remote
So
controller,
machine has a
AC wala
main
remote
computer.
in a display එකක්. There you have a driver, software by the manufacturer. You can't change that. That is
So
read
near the
only. You can't change. Read only. You can maybe change the settings, but you can't erase the software and change it. Understood what is wrong?
yes sir.
In each hardware you have ROM, right? Each hardware component, there's a ROM. Read only memory. ඒ read only දැන් pen drive එකේ ROM එකක් තියෙනවා. Read only memory එකක් තියෙනවා. To that read only memory. That's why pen drive takes some space, additional space. 8 GB pen drive will not give all 8 GB to you. It has some space allocated for its drivers and the file system.
Oh, that's why it's always less.
It's always less. Hard drive, if you get 500 GB hard drive, you get 449 something because it has a driver.
10 GB for driver. Oh my god.
Hmm. It uses some space for driver and this file allocation. So that's why, right? So any hardware has a ROM chip stored in the driver related to the particular. That's how the other components are recognized the particular component. Communication party is that software because hardware cannot communicate to each other without that software. So that those software components are called firmware. Firmware means stored at the firm. Washing machine, TV, radio, ඕන එකක තියෙනවා. That's wrong. But we are not going to check that. ඔයාලා අහලා තියෙනවද mobile phone අර country lock කරන, country unlock කරනවා කියලා කියන්නේ. Something called unlocking the country.
R sim.
Yeah, so then country lock in, country unlock in, and maybe reflashing. So what it does basically erasing this ROM and so ROM is anyway read only, but these special ROMs are erasable. Those are called flash ROMs. But erase can be erased using special software or special tool. So you can erase and put the software back. Software ගහනවා කියලා ආයෙ කරන්න phone වලට. Just erasing the software in the ROM and reinstalling the software that you want.
The phone.
Yes, can be done.
So it won't like. Will we get the genuine, the original one?
Not genuine. The warranty will be removed. So because you have done modification.
But still, is it secure?
Yeah, it's okay. No issue. But some vulnerabilities might come. So because if you, this, for an example, if your phone is built for Android Lollipop, if you update that phone by erasing the Android Lollipop and you update that to some other Android version, so
phone
since
might
it is
slow.
built for Android Lollipop, sometimes there can be vulnerabilities. But still, it's possible to update, erase and put the new software. That is possible. Okay, then, so now you know these components. Then the CPU, the processing part, the processor. Cache memory, you saw that. It's there in that cache memory. L1 cache is inside this. L2 cache is also inside, but L3 cache is outside attached to this. Right? L1 and 2 mostly inside. L1 anyway, it's surely inside. L2 inside වෙන්නත් පුළුවන්, outside වෙන්නත් පුළුවන්. It's half. But L3 is outside, surely outside. Outside but attached to the CPU.
But
These are some
everything
additional
are
memories.
in the processor, right?
Yeah, it's in the processor. So why there's a memory inside the processor? Because you have memory, separate one. Why you need memory inside the processor? These memories are relatively very small. You can see, very small. Yeah, 640 KB, 640 KB, kilobyte, very small memory. Why? You have 31 GB, 32 GB RAM. Here also you cannot see 32, right? 31.7. You know the reason. Because some part is allocated.
That's cache memory. That's why, yes.
Right, okay. Why this cache memory?
It's the fastest storage thing,
Yeah,
right?
it's a fast storage. Why does it
So
inside the processor? So because you have a separate memory. Why that cache memory thing?
to run the processor,
So
to boot
it's something
up
like
or
this.
to start.
You buy a loaf of bread from shop, right? That is your secondary storage. Then you get some slices. You cut it to some slices. Now you take that slices, that is pages in the main memory. So why these slices? කෑලි ටිකක් කපලා ගන්නයි පාංගෙඩි. Because you want to eat it now. Currently processing things will go to the currently running things will go to the main memory. Similar to that, the slices are now in your plate. These slices are similar to pages. Now
Oh,
it's in your plate. Then the CPU, that is your mouth, you are going to process. You take a piece of that slice and put it inside your mouth. You need space in your mouth, no? Otherwise, what will happen? Can you eat? If you don't have space in your mouth, what will happen? Can you eat? පුළුවන් ද කන්න කටේ ඉඩ නැත්තම්? Can you take a piece of bread? So here actually slices are in the main memory that you are going to eat now. That is your plate. දැන් කන්න යනේවා තමයි main memory එකේ තියෙන්නේ. එතකොට ඒකෙන් කෑල්ලක් කඩාගෙන දාගන්නවා CPU එකට because you want to eat now. So that piece will take space. That is your cache memory. That's similar to your mouth. Mouth has space. If you are like a crocodile fellow, then you have a big mouth where you can swallow the entire bread. But if you like this cockroach or some small kind ant or someone, but then you can't eat the entire thing. You have to take small piece and try to eat. So anyway, for the processing purpose, you need memory. That is this one. Understood?
Yes, sir.
Right. Then why you need registers? Registers is another memory.
registers
Wow.
is to
So small stuff.
yeah.
Yeah, small. That is for you have mouth. That is true, but you have teeth also. In
The
that
teeth
teeth,
don't store anything, no.
yeah,
The temporary storage like
yeah, those are temporarily. Temporary. You can just
RAM,
yeah.
not volatile, non-volatile. No, volatile.
Don't confuse, right? RAM is volatile.
Yeah,
RAM is
volatile.
volatile. Non-volatile one is hard disk. Volatile means this depend on the
Then ROM
voltage.
is non-volatile, right?
ROM is non-volatile. ROM is non-volatile. ROM
So
is
it's not.
read-only, no? It's non-volatile. It's all stored by the manufacturer. It's already there.
No.
But hard disk is also non-volatile. But this memory, RAM, this cache memories, main memories, those are volatile because when power is not there, nothing will happen there. Current එක නැත්තම් දැන් මුකුත් ඇත්තෙත් නැහැ. Nothing to process, nothing to memorize if power is not there. Right? Therefore, all RAMs will sleep when power is not there. That's why RAMs are volatile. Okay, anyway, don't confuse, right? So why you need registers? Because it's like your teeth. And why you are using that? For chewing and maybe so to processing purpose, you need
Typing.
small memory cells.
Mm.
දැන් අපේ තියෙන දත්වාර අර ටොන්තක රදනක පුරස්චාරක චාරක like us we have like wisdom tooth everything is there. So why this? Because it's assisting these registers, these different type of registers are assisting us in processing. That's similar to our okay. So now so why different levels of storages are there? So you have the bakery, which is this is Ethernet or the network. From bakery you have bread, that is your hard disk. Then you have slices, that is your main memory. Then you have pieces in your mouth, that is your cache. Then you have teeth also. So likewise, you have different levels of
Sir,
memory.
but this cache will never move, right? It's the same, right?
Yeah, it's a so if you want to change the cache, what will happen? You need to change the processor.
Oh.
You can't change your mouth, but you can't change your plate. Right? So you can change your plate, but you can't change your mouth. So it's similar to that. Cache you can't change. But plate you can change and you can make it bigger one. Right,
Yes.
now you have the idea about these things. And what is ALU and CU now we learned?
CU controls it's the
Yeah, it
controller,
sends the control signals to all the hardware components.
mouse, keyboard,
Yes,
speaker.
mouse, keyboard, speakers. It's
Yes.
like traffic police. So it's not
Mm.
like traffic police is not driving. No? In a junction, if you see
Mm.
traffic police, in junction,
Yes.
if you see a traffic police, you can see he's not driving, he's signaling. He's
Yes.
showing what to do, signaling and telling us what to do, but he's not driving. So similar to that, CU
Yep.
is not driving, CU is not doing anything, but it's signaling other hardware to, or it instructing other hardware to do something. So that's
Mm.
basically ALU. CU. ALU is basically responsible for arithmetic, mathematical and logical comparison
Plus
like operators and mathematical operators. That is our ALU.
calculator.
Okay, then so dynamic RAM. Dynamic RAM is the traditional RAM. This one, RAM. If you search RAM, you will get this one. So if you search DRAM versus SRAM, then anyway you can't see the DRAM, SRAM. Here you can see SRAM and DRAM. SRAM is a chip, is inside, but DRAM here
These
it's
are
like a
inbuilt
part.
to the motherboard.
Sorry,
These are inbuilt to the motherboard.
SRAM is inside the processor.
Inside the processor.
Yeah, it's inside the processor. That's why I said L1 cache, L2 cache inside the processor.
Yeah, yeah. No, this also can it fit inside?
So this one in the picture, in
Yeah.
this picture, this is showing some other SRAM, right?
Oh.
Some other SRAM. This is not the one in your motherboard. So this can be level 3 cache. L3 cache can be like this. It's a chip. But L1 cache, L2 cache, it is inside the processor. And SRAM and DRAM, you should know these differences, which is faster is SRAM and more costlier is SRAM. And so both need, like, both are volatile, right? So SRAM is basically inside the SRAM, you can't change as you wish, but DRAM you can change, right? These are the things that you should learn about SRAM and DRAM. Okay, then now we know the components. Now we can answer the question. Okay. Calculate the average using Excel. To do that, you have to open Excel from storage. Okay, you have to open Excel, open Excel to RAM from hard disk, which is storage. It's there in hard disk, you have to open it to the RAM. After opening, you can input. Then you can, inputs will go to the memory. And when inputs will go to the memory, same time it will go to the processor to process, and it will be presented as the output, right? So first you have to open, then you have to input the numbers. You have to calculate the average, no, input the numbers, and it will go to the memory. Then the calculation part will happen in the processor, and it will be presented to us using output devices. So that is the process when calculating something using Excel. Installing software by downloading it. So it will first load to open the browser from storage to RAM, then input, and inputs will go to the memory, and that will go to the processor, and processor will understand that, and then, so according to the command, the downloading will happen. So basically down